This is Professor Forsythe's MAT0022C Developmental Math Combined Final Exam Review. So what I'm going to do is try to work through as many problems as I can from the Final Exam Review over the next 2 hours. If you have any questions as we go through these, please you can type in the chat box and I can see the question and answer it if you want to say something. But please don't hesitate to ask questions. I don't see me going over every single problem in the review just due to time, and I end up taking longer to explain things. But yeah, hopefully this is a good use of 2 hours. So I'm going to get started, and I need to kind of get situated. Let's see. Okay. Okay, so we're going to begin with solving this equation. Okay, so to solve this equation, the goal is to solve for the variable, get x by itself. So before we can do that, we need to simplify each side of the equal sign and then isolate the variables. So on the left, we want to distribute this 4. We have 4 times 5x plus 35 equals 100. So we're going to start by distributing the 4. So we have 4 times 5x, and then we have 4 plus 4 times 35 equals 100. So 4 times 5x is 20x plus 4 times 35, so 35 times 4. 5 times 4 is 20, 0, carry the 2. 4 times 3 is 12, plus 2 is 14. So we have 140 equals 100. And so we want to get the x term by itself. So we're going to subtract 140 from both sides of the equal sign. So on the left I have 20x. 140 minus 140 cancels out, equals 100 minus 140 will be negative 40. And then to solve for x and get x completely by itself, we're going to divide by 20 on both sides. So then 20x divided by 20 leaves me with x equals, and then negative 40 divided by positive 20 is going to give me a negative 2. So this is my solution. And just so you know, you can always check an equation's answer by plugging it back into your equation. So you would have 4 times 5 times negative 2 plus 35 equals 100. So that'll be 4 times negative 10 plus 35 equals 100. In the parentheses, negative 10 plus 35 is 25 times 4 equals 100. And 4 times 25 is 100. So we know we have the correct answer. So just don't be afraid to check your answer as you do your final exam, especially in your final exam review. Okay, number 2, solve this equation. So we have 4 times, open parentheses, 5x minus 1, close parentheses, equals 3 times, open parentheses, 6x minus 1. So we're going to distribute the 4 on the left-hand side. So we have 4 times 5x, and then minus, and then we have a positive 4 times negative 1 equals, and then distribute this 3. So 3 times 6x plus 3 times negative 1. Okay, so on the left, 4 times 5x is 20x. 4 times negative 1 is negative 4 equals 3 times 6x is 18x plus 3 times negative 1 is negative 3. So now I have variables and constants on both sides of the equal sign. So I want to put my variables on one side and my constants on the other side. So let's go with the x terms on the left. So I'm going to subtract this 18x. So on the left, 20x minus 18x is 2x. Bring down that minus 4 equals 18x minus 18x cancels out. I'm going to bring down that minus 3. And then now that I have my variables on the left, I want to put my constants on the right. So I'm going to add the 4. So this will cancel out and add 4 to the other side. So I'm going to bring down that 2x equals negative 3 plus 4. So different signs, subtract, take the sign of the larger number. So this is going to be a positive 1. And then finally, to solve for x, we're going to divide by 2. So x equals 1/2. That's going to be our solution. X equals 1/2. Okay. Number 3, solve. So we have negative 5y plus 3 times negative 7y plus 8 equals negative 2 plus 4 times 4 minus y. So I'm going to start by distributing the 3 on the left. So I have negative 5y plus 3 times negative 7y plus 3 times 8 equals negative 2 plus 4 times 4 plus 4 times negative y. So let's clean this up a bit. So I have negative 5y. 3 times negative 7y is negative 21y. 3 times 8 is 24 equals negative 2. 4 times 4 is 16. 4 times negative y is negative 4y. So I have some like terms I can combine. Over here I have negative 5y minus 21y. So same signs, add and keep the signs. So it's going to be negative 26y plus 24 equals, I have more like terms here. Negative 2 plus 16. So that's different signs, so we subtract and take the sign of the larger number. So that'll be a positive 14 and then minus 4y. So now I want to move my variables to one side of the equal sign and my constants to the other side of the equal sign. So I'm going to move this negative 4y on the other side. So I'm going to add it. So it'll go away on the right and move to the left. So, hold on. So on the left, negative 26y plus 4y. Different signs, so we subtract, take the sign of the larger number. So it's going to be a negative 22y. Bring down that plus 24 equals 14. And I'm going to subtract the 24. So I'm going to bring down that negative 22y equals 14 minus 24. Different sign, subtract and take the sign of the larger number. So that's going to be a negative 10. And then now, let's go over here. Negative 22y equals negative 10. I'm going to divide by negative 22 so I can get y by itself. So I have y equals negative 10 divided by negative 22 is going to be a positive. And we can divide 2 into both of these. 2 can go into 10 5 times. 2 can go into 22 11 times. So we have positive 5 over 11. And that's going to be our final answer. Okay. Let's keep going. Number 4, solve. So we have decimals here. So 4p minus 2.8 equals 3.9p minus 1.84. So you can do this a couple of ways. You could, if I had a question, nope, no question. You could, if you wanted to, make them all whole numbers by multiplying by a power of 10, or we can keep it as it is. I'll probably just keep it as it is. So let's move all of the p terms to the left-hand side. So I'm going to subtract 3.9p. So on the side here, I'm going to do 4 minus 3.9. I have to line up the decimals when I'm adding or subtracting. That'll be 4.0 minus 3.9. So I'm going to borrow from the 4. So I'm going to have 10 minus 9 is 1, and 3 minus 3 is 0. So it'll be 0.1p. Okay? So 0.1p. Let's bring down that minus 2.8 equals negative 1.84. And then now I'm going to add 2.8 to both sides. Okay, so let me bring down the 0.1p equals, now negative 1.84 plus 2.8. So I have different signs, so I'm going to subtract and take the sign of the larger number. So since the 2.8 is bigger than 1.84, the answer is going to be positive, so I'm going to take the difference. So I'm going to do 2.8 minus 1.84. So I'm going to put a 0 here as a placeholder. I'm going to borrow from here. 10 minus 4 is 6. I have a question. Let's see. Can you turn them into fractions? So you could, but let me see with the question how they want the answer. I mean, you could change them into fractions, and I'll put the answer as a fraction in the if that's easier for you, you could, but you'd want to answer it as a decimal. If the problem starts off as a decimal, you want to answer it as a decimal. But if it's easier to change it to a fraction, you can. Just keep in mind, you cannot use a calculator on this test. So just keep that in mind. Okay. So where was I? All right, so I'm finding the difference. So then 10 minus 4 is 6. 7 minus 8, I need to borrow over here. 17 minus 8 is going to give me a 9. I'm going to have the decimal there. So it's going to be a positive 0.96. And then now to solve for p, I'm going to divide. I want it red. Divide by 0.1. So I'm going to have p equals, and let's do that division over here on the side. 0.96 divided by 0.1. And if you wanted to, you could multiply them by powers of 10. I would do that over making them fractions. That was the question about could you make them fractions. I would multiply everything here by 100, and then you would just have a bunch of whole numbers, and you would get the same answer. Okay, so if I move the decimal, I have to move it once here. So I move it one time here. So this is where the decimal will be in my answer. So 1 divides into 9 times. 9 times 1 is 9. Subtract. Drop the 6. Okay. 1 goes into 6 times. 6 times 1 is 6. Subtract, I have a remainder of 0. So P equals 9.6. So that is going to be your final answer here, 9.6. What I was saying earlier was that you could, so if you notice in the beginning, you have 2 decimal places, that's the biggest number. So if you multiply everything by 100, then you would end up with 400p minus 280 equals 390p minus 184. If you solve that, you will end up getting the same answer of 9.6. So I would do that before changing them to fractions for the student who had the question about changing them. Okay, let's keep going. Number 5, solve 1/2 x plus 1/4 equals -5. Now here, I would definitely clear the fractions by multiplying the entire thing by a common multiple. So you've got 2 and 4. So you could multiply everything by 2 times 4, and you would get rid of those fractions. So if we find a common multiple, 2 times 4 equals 8. Let's multiply everything by 8 and see what happens. So we have 8 times 1/2 x plus 8 times 1/4 equals 8 times -5. Watch what happens. So 8 over 2, or 8 times 1 divided by 2, is just going to be 4. 4x plus 8 times 1 is 8 divided by 4 is 2 equals 8 times -5 is -40. No more fractions. Yay! Okay. So now, and they want for this problem to write your answer as an integer or a reduced fraction. Okay. So now we're going to subtract 2 to start getting the x term by itself. So then I'm going to have 4x equals -40 minus 2, same sign, so you add and keep the sign, -42. And then to solve for x, I'm going to divide by 4. So x equals -42 divided by 4. Now you can reduce this. It says it wants it as a reduced fraction, so you have to reduce it. So you're thinking about what numbers can be divided evenly into both of these. If they're both even, you know 2 can go into both of them. So let's start with that. So if we divide the top and bottom by 2, I'll end up with -21 over 2. And then if you think about this, you can't divide this further. So x equals -21 divided by 2. That would be your final answer there. And this is, let me make sure you know what I'm saying here. This is a common multiple using denominators. You could have multiplied everything by the least common denominator, or the least common multiple, which would have been 4, and you would have actually gotten to your reduced answer quicker. But even if you didn't do that, you multiplied them by a common multiple, you'll still get to the same answer. Okay, number 6, solve for L. This is called a literal equation. So we have P equals 2L plus W. 2L plus 2W, sorry. So we're solving for L. So make sure you can identify where it is. This is L. We want to get that yellow L completely by itself. So to start that process, we move the 2w. So it's plus 2w. Let's subtract 2w. Now what I think is the most different thing about these is that you're solving for a variable, but you're not going to end up with like L equals 4 or L equals negative 10. You're just kind of rearranging this equation to where it's set equal to a particular variable, but you're probably not going to make it smaller. Like, you know how you take a long equation and then you solve it and you end up getting like a variable equals a number? Here, you're just going to kind of rearrange the puzzle pieces. So on the left, I've got P minus 2w equals 2L because the 2w canceled on the right. So again, I'm solving for L. So I've got the term that has L by itself, but I want to get L by itself. So it's 2 times L, so I want to divide by 2 so that the 2 will cancel on the right, and I'll just have L equals everything else. So on the left, I have P minus 2W divided by 2 equals L. You could split that up if you wanted to, but you don't have to. You can just leave it just like that. In iMathAS, it says L equals, and it has a blank. Make sure you use the math script help in the software, or you type parentheses around your numerator and denominator. So you type P minus 2W divided by 2, and make sure it looks like what you think it should look like. Okay? All right. Number 7, solve this inequality. And we're going to write the answer in interval notation. Okay, so we're going to solve this as if it was an equation with equal sign. So let's move the x terms to the left. So I'm going to start by subtracting 7x. On the left, I'm going to have 12x minus 7x, which is 5x. I'm going to bring down that plus 2, which is greater than or equal to negative 19. And 7x minus 7x cancels out. Next, I want to get the x term by itself. So I'm going to subtract this 2. So then on the left, I bring down that 5x is greater than or equal to negative 19 minus 2. They have the same sign, so we're going to add and keep the sign, negative 21. And then finally, to solve for x and get it by itself, I'm going to divide by 5. So x is greater than or equal to negative 21 over 5. So I want to write that solution in interval notation. So I like to first graph it and then use the graph to then write interval notation. So I only have one value here, which is negative 21 over 5. So I'm just going to stick it right there in the middle. And it says that x is, and this says greater than or equal to. That's what this is saying. So, greater than or equal to. So all the values, for my number line, before I just keep going, the very left side is negative infinity. The very right side goes on to positive infinity. Okay, so all the values greater than negative 21 over 5 are going to be to the right of it. So we're shading all of that all the way to infinity. And it says greater than or equal to. So we are going to include that negative 21 over 5 as well. So this is my solution on a graph, all this blue. Let's take that graph and translate it into interval notation. So we always go from the left to the right. So your blue shading starts at negative 21 over 5. Now we are including it. It's a closed circle, so we're going to use a bracket for that. And then the interval is going all the way to infinity. So we're going to put a comma and then write infinity. And infinity always uses parentheses. So this is my solution here. in interval notation. This is the solution in what's called set builder notation. This is interval notation in the yellow. Okay. Number 8, graph and solve and graph the solution. Sorry. Okay, negative 6x plus 2 is less than or equal to 20. So to solve for x, I'm going to start by subtracting 2. So I have negative 6x is less than or equal to 20 minus 2 is 18. So now I'm going to solve for x by dividing by negative 6. Now, when you divide by or multiply by a negative across an inequality, you have to flip your inequality sign. So that less than or equal to changes to greater than or equal to because of this negative. So I have x is greater than or equal to 18 divided by negative 6. It's going to give me a negative 3. This is the solution here. And now to graph it. So I have a number line. I have one value of negative 3. All of the values greater than negative 3 are to the right. And it's greater than or equal to, so I'm going to use a closed circle. And this is going to be my graph of my solution. Okay, number 9, find the perimeter of the rectangle. So, this is a rectangle. They give you 2 dimensions. Know that if opposite sides are equal in a rectangle, so this is 30, the length I guess is 30 centimeters, this must be 30 centimeters as well. And if this height or width is 10 centimeters, this is 10 centimeters as well. So you could do it 2 different ways. The perimeter means that you add up all the sides. So you could just say 30 plus 30 plus 10 plus 10, which would equal 60 plus 20, which equals 80 centimeters. Or you could use this formula, perimeter of a rectangle equals 2 times the length plus 2 times the width. So that'll be 2 times 30 plus 2 times 10, which will give you 60 plus 20, which still equals your 80. Either way you go, you would get the same answer. Okay, number 10, a rectangular room is 4 times as long as it is wide, and its perimeter is 80 meters. Find the width of the room. So let's sketch this out. So it says that it's 4 times as long as it is wide. So if this is your width, we'll say that's x. This is 4 times x. And its perimeter, if you add up all the sides, equals 80 meters. So if we use that perimeter equals 2L plus 2W, we could say 80 equals 2 times the length of 4x. And then you may want to put here x represents the width. So you keep that in mind. Plus 2 times x. So we'll have 80 equals 2 times 4x is 8x. 2 times x is 2x. 8x plus 2x is 10x. 80 equals 10x, and then if we divide by 10 to solve for x, 80 divided by 10 is 8. And so it's asking for the width of the room. And remember we said that x equals the width, so the width will be 8 meters. It will be 8 meters. Okay. Number 11. Okay. Carpet sells for $3 per square foot and will cost you $684 to recarpet your rectangular room. If your room is 19 feet long, how many feet wide is it? Okay. So, let's just sketch this out. 19 feet long, square foot. So each little square foot is $3, and it will cost you $684 to recarpet your rectangular room. If your room is 19 feet long, how many feet wide is it? So let's see here. I want to make sure. Okay. So let's think about it like this. So if we were to say, okay, how much would it be if it's $3 per square foot and it'll cost you $684 to recarpet the rectangular room? We can use that information to figure out how many square feet is the rectangular room. So if it's $3 for each square foot, 684 divided by 3 will give you how much the area of the room is. And so 684, let's see, 684 divided by 3. So 3 can divide into 6 2 times. 2 times 3 is 6. Subtract. Bring down the 8. 3 goes into 8 2 times. 2 times 8 is 6. Subtract. Bring down the 4. And 3 goes into 24 8 times. 8 times 3 is 24. So the area of the room is 228 square feet. So if we're trying to find this value, x is how many feet wide. So 19 times x equals 228. Because the area of a rectangle is length times width. So to solve for x, we're going to divide by 19. So then let's do that over here on the side. So 228 divided by 19. So 19 can go into 22 one time. 1 times 19 is 19. We're going to subtract. That's going to give me, let's see, 23. Bring down the 8. 19 goes into 38. 2 times. 2 times 9 is 18. Carry the 1. 2 times 1 is 2. Plus 1 is 3. So 0 remainder. So x equals 12. So how many feet wide? That would be 12 feet. 12 feet. Okay, next question. Lisa's rectangular living room is 20 feet wide. If the length is 5 feet less than twice the width, what is the area of her living room? Okay, so we have a rectangular room. Our rectangles are so sketchy. Let me try this. That's a little better. So it's 20 feet wide. So this will be 20. If the length is length is 5 feet less than twice the width. So 2 times the width, which is 20, 5 feet less than that. So we're going to subtract 5 from that. So that means the length will be 2 times 20 is 40 minus 5, which is 35. What is the area of the living room? So remember, area of a rectangle is length times width. So for this, that'll be 35 times 20. So 35 times 20. 0 times 5 is 0. 0 times 3 is 0. Put our placeholder, and 2 times 5 is 10. Carry the 1. 2 times 3 is 6, plus 1 is 7. And then we're going to add, going down. So the answer is 700 square feet. Is that feet? Yes, square feet. That's your answer there, 700 square feet. Okay, 13. A retired couple invested $21,000 in bonds. At the end of 1 year, they received an interest payment of $1,533. What was the simple interest rate of the bonds? So your simple interest formula is interest equals PRT, principal times rate times time. You may hear it called the PERT formula. So the capital I, that is the interest that you get, or you get. P is how much you invest, your investment. The P stands for principal, but I'll just say investment. R is the rate, and then T is time in years. Okay, so let's plug in what we know. So I, in this case, the interest is $1,533. The investment was the $21,000. The rate, what was the simple interest rate? That's what we are solving for. And then the time, how much time went by? 1 year, so time is 1. So let's plug in our numbers into the formula. So 1,533 equals 21,000 R times 1. So it's just 21,000 R. So we are trying to solve for R, so we're going to divide by 21,000. Okay, so we've got 1,533 divided by 21,000. Okay, so that is larger than this, so we're going to add some zeros in here. Okay. So 21,000 cannot go into 1,500. 21,000 cannot go into 15,000. So 21,000 can go into 153,000. Let's see. You got to just kind of like play around and try some numbers. So let's think. 20,000 times 5 is 100,000. We're looking at 150,000. So 100,000 plus another 20,000 would be 120. That's 6. 140. That'd be 7. Let's start with 7. Okay. So 7 times 0 is 0. 7 times 0, 0. 7 times 0, 0. 7 times 1 is 7. 7 times 2 is 14. Now we're going to subtract. So we've got 0, 0, 3. We need to borrow from this 5. We have 13 minus 7, which is 6. 4 minus 4 is 0. 1 minus 1 is 0. Okay. So now we need to keep going because we want to, this says to round the answer. Let's see, do not round off a decimal answer. Do not include a percent. Okay. So now we're going to add a 0 here. Now, 21,000 goes into 63,000. That actually goes in there. I think I'm missing a 0. Hold on one second. Oh, I should have written that. I wrote that in the wrong spot. Hold on one sec. Let me start over really quick. All right, let me rewrite this. So it's 1, 5, 3, 3. Okay. All right. So now 15. It didn't go into 15,000, so that was a 0 there. It went into 153,000. So this is where the 7 should have gone. And then, oh, I forgot what the number was. So 0, 0, 0, 7, 14, 0, 0, 3, borrow 6. Okay, cool. Now we're going to add a 0 and do it again. There we go. 21,000 divided into 63,000 3 times. 3 times these 3 zeros. And now 3 times 1 is 3. 3 times 2 is 6. There we go. Subtract, remainder 0. So this is saying that R equals 0.073. Keep in mind that in the formula, the rate is as a decimal. We want to change this decimal to a percent. So to change a decimal to a percent, we move the decimal 2 places to the right. So that's actually going to be 7.3%. So remember, the reason why the 0 goes here is that as I was putting my dividing through, I was dividing 21,000 into 153,000. So this was the number here it was dividing into. So that's why I had to put a 0 here for that placeholder. Okay. There we go. Okay, let's keep going. Okay, 14. After dinner, Amanda, Trey, and John received the check for their meal. Trey is paying 1/4 of the check and leaving no tip. Amanda is paying the remainder of the check. John is leaving 20% of the check as a tip. Using C as the amount of the check, match each person with an appropriate algebraic expression. Okay, so let's just start with what they tell us. So look at Trey. So Trey is paying 1/4 of the check. So remember that 1/4 is equal to 0.25. Okay? So if he is paying 1/4 of the check, he is going to multiply 1/4 times the value of the check, or multiply 0.25 times the value of the check. So Trey would be 0.25 times C. Okay, let's look at, and leaving no tip. That is not nice. So Amanda's paying the remainder of the check. So if he is paying 0.25 of the check, 100 minus 0.25 equals 0.75. So Amanda's paying 0.75 times the check. So that would be Amanda. And then John is leaving 20% of the check as a tip. So he is going to pay, so we're going to change 20% to a decimal. So that's 20. So change that to a decimal. We're going to move it 2 to the left. So that's going to equal 0.2 as a decimal. So that's going to be John, which is A. And so there's no match, so this will have to be B. This would mean that somebody's paying for the entire check plus 20% of the check. So this would be the check, what the check is plus the tip that John is leaving. Okay. All right, 15. An antique has a price tag of $102. The sales tax rate for the county is 8.1%. How much sales tax will be due? Write the answer to the nearest cent. Okay, so we want to find 8.1% of 102. So to do that, we're going to change 8.1% to a decimal. So 8.1% is going to equal 0.081 because we move it 2 places to the left. So now we're going to take 0.081 times 102. So when you multiply decimals, you don't have to line the decimals up, okay? And actually, you can ignore the decimal in general and make it a whole number. But, so now, we're going to just multiply. 1 times 2 is 2. 1 times 0 is 0. 1 times 1 is 1. See, I've got a question. Oh, did you find the answer? Oh, good. Let's see if it's right. Wait. How did you get that? Yeah, 82.62. What is 82.62? This is what a student put in the chat room. Okay. So where are we? 1 times 2 is 2. 1 times 0 is 0. 1 times 1 is 1. The placeholder of 0. 8 times 2 is 16. Carry the 1. 8 times 0 is 0 plus 1 is 1. 8 times 1 is 8. And I don't have to do it with a 0 because that's not going to change anything. So now we're going to add. 2 plus 0 is 2. 0 plus 6 is 6. 1 plus 1 is 2. And then bring down the 8. Oh, okay, I see what you were doing. Now, how many decimal places do we have? We have 3. 1, 2, 3. 1, 2, 3. So we move it 1, 2, 3 places, and that's where the decimal goes in your answer. So the answer is 8.262, but it says round to the nearest cent. So that is the second decimal place here, the nearest hundredth. So that's going to be $8.26. Whoa, hold on. Sorry about that, guys. Sometimes the computer jumps. Okay. So, yeah, so the student, you said 82.62. It's 8.26. So because it was 0.081, you move it 3 decimal places to get that. So I hope you see that. Do you have any questions about that? And if not, we'll just keep going. But a good job trying that out. Very good. Okay. At a restaurant, the bill comes up to $70. If you decide to leave a 13% tip, how much is the tip? And FYI, you won't have to find the tip multiple times on the final. Your reviews are actually 10 questions longer than the final. So your final is going to be 30 questions. Your reviews are 40 questions. Just a little note for y'all to know. Okay, so we want to find 13% of $70. So we're going to change 13% to a decimal. So 0.13 times 70. So we have 70 times 13, 0.13. 3 times 0 is 0. 3 times 7 is 21. 0 placeholder, and 1 times 0 is 0, and 1 times 7 is 7. So we're going to add this up, 0, 1, and 9, and then we need to move it 2 decimal places. So the answer is going to be $9.10. Okay, so next we're going to look at some graphing. This is chapter 3. So find the x-intercept of the line represented by the equation negative 5x plus 3y equals 45. So to get the x-intercept, we want to make y equals 0 and then solve for x. So that's going to be negative 5x plus 3 times 0 equals 45. So we have negative 5x, 3 times 0 is 0, equals 45. So negative 5x equals 45. And then to solve for x, we're going to divide by negative 5. So x equals 45 divided by negative 5 is negative 9. Now notice it says to write it as an ordered pair. That's very important. If you don't write the answer as it asks for it, you'll get the wrong answer. If you just type in negative 9, that is not going to be the answer. This is a point on the line. Okay, this is where your line crosses the x-axis. It's a certain point. So an ordered pair is x comma y with parentheses around it. So for this, your x-coordinate is negative 9, and the y-coordinate, remember, is 0. So this is going to be your answer, negative 9 comma 0 with parentheses around it. So please type it properly, okay? If you just type negative 9 comma 0 with no parentheses, MAT0022C is not going to read that as an ordered pair, okay? All right, 18 is now asking for the y-intercept. So to get the y-intercept, you're going to make x equals 0 and solve for y. So that'll be negative 3 times 0 plus 2y equals 12. So negative 3 times 0 is just 0. Plus 2y equals 12. So we have 2y equals 12, and then to solve for y, I'm going to divide by 2. So y equals 12 divided by 2, which is 6. But again, write it as an ordered pair. So the ordered pair is x comma y. So for this problem, it'll be 0 comma 6. That would be your y-intercept, written as an ordered pair. Okay, 19. Find the slope of the line that passes through the points 15, 0, and negative 12, 14. So the slope formula, when you're given 2 points on a line, is y2 minus y1 divided by x2 minus x1. What you're basically doing is that you are subtracting your y values and dividing it by the difference of your x values. So it's helpful if you label your points. It actually doesn't matter which one is your first point or your second point, as long as you're consistent. But I'm going to label, so make this x1 and x1 and y1, and this can be x2 and y2. Okay, so y2, I've got it labeled as 14 minus y1, I have labeled as 0, divided by x2, I have labeled as negative 12, minus x1, I have labeled as 15. So 14 minus 0 is 14, and then negative 12 minus 15. It's the same sign, so I'm going to keep the sign and add. So 12 plus 15 is 27. And then you cannot reduce this further because 14, what? I don't know what just happened. Sorry. 14 and 27 don't have a common factor. So your answer is just negative 14 over 27. That is the slope of the line. Would this line be increasing from left to right or decreasing from left to right? It's a little, see if you guys are still with me. If the slope is negative 14 over 27, would the line be decreasing from left to right or increasing from left to right? Decreasing. Yes, you get the grand prize of a virtual high five. Excellent. You too. Both of you guys get that. Excellent, excellent, excellent. Okay, let's keep going. So this one, find the slope of the line. So I just took a screenshot of it from MAT0022C. So the best way to do this is to kind of find two clear points. So like, we'll go with this and that. So remember, slope is rise over run, which means your movement from one point to the other, up or down, divided by left or right. So let's use some colors here. So let's do up and down. So let's see, if I go from here to here, I'm going to go 1, 2, 3, 4, 5. 5 down. So that would be negative 5 would be the rise. Okay, let's see left to right. So let's see, I will go 1, 2, 3, 4. 4 to the right, that's going to be positive 4. So my slope would be negative 5 over 4 because that can't be simplified anymore. And those are the best places, because the thing is, like, this, like, say for example, you see how this part here is not on like a grid intersection? You want to try to pick very clear integers for your points. Like, you don't want to count from like here to like here, because you don't know how much you're actually moving, right? So you want to pick places that are very clear to see when you're counting your slope. So the question is, so to answer these, you just find 2 points. So you just need to count. If you're given the graph, you just really need to count your rise over your run. You could find the points and then use the algebra. So like this point here would be 0, 3. And this point would be 4, negative 2. So if we use the slope formula, y2 minus y1 over x2 minus x1, you could say negative 2 minus 3 over 4 minus 0, which gives you negative 5 over 4. So you could find 2 points and use the formula, or you could just literally count your rise over run, even if you went the other way. So like if we went up 5, that's positive 5, and then we went to the left 4, I want blue. Went to the left 4, that would be negative 4. That's still going to give you the same thing. So either way, you can either count your rise over run from one point to the other, or you can identify the points and then plug them into the slope formula. You'll get the right answer either way. Excellent question, though. Okay. 21. Determine the slope. So now you're finding the slope a ton of different ways. The previous question, so we found the slope so far 2 different ways. One way is that we were just given 2 points on the line and we use the slope formula. The last way, we were given a graph. Oh, you're quick, yes. We were given the graph and then we counted the rise over the run. And then here we're just going to look at it and identify it. So this is in slope intercept form. I love it. Y'all are on it. If y'all could see what I see. Oop, what happened? Sorry, these students are on it. Okay, so slope intercept form is y equals mx plus b. So m is your slope, and b, oh, I want it green. I love my colors. Y'all haven't figured that out. B is your y-intercept. This form is like one of the most helpful ways of dealing with linear equations that you'll ever deal with. So all you got to do is look at the equation. If it is in slope-intercept form, which this is, if you can see, it looks just like it in terms of the form, the coefficient of the x term is your slope. So if m is the slope here equals 1/2, just like you guys said in the chat. Good. The y-intercept would be 1. Good. Okay, so for this one, they don't give you the equation in slope-intercept form, but you just want to rewrite it. And then you can tell what it is. So this is slope-intercept form. So you want to solve for y and get y by itself. So to do that, we'll add x to both sides, move that x over there on the other side. So then we'll have y equals, and let's put it in this form. So we're going to put the x first, then the plus 11. So now they're in the same form, and then we're looking for the coefficient of the x term, which in this case is a 1. So the slope equals 1. Okay? Okay, this is freezing. Okay. Oh, too fast, too fast. Okay, now this one says, which of the following graphs represents the equation? So you can go about this a couple of ways. You can kind of rule out some things. So for one, it's in slope-intercept form, so that's super helpful. So the slope of this equation is -3/2. So for one, and you guys already answered this for another question, if the slope is negative, that means your line should be decreasing from left to right. So that rules out the first and the third, because those are increasing from left to right, so that slope has to be positive. So now you just got to look at which one has a y-intercept of +1. And the y-intercept is where the line crosses the y-axis. So this one is crossing the y-axis at -1, but this one's crossing at +1. So this is going to be your answer. So that's a way that you can answer that question, by just kind of eliminating things and then using that information that you know with slope-intercept form. Okay. 24. Now we're in chapter, I think, 4. Simplify. So we're going to combine all of our like terms. Let's see, and we want to write it in standard forms. Let's put our exponents in decreasing order. So we've got x to the 4th, so negative 7x to the 4th minus 10x to the 4th. Next we have x to the 3rd, so plus x to the 3rd plus 3x to the 3rd. And then we have an x term, 2x, and we have a constant, minus 9. So let's combine our like terms here. So negative 7x to the 4th minus 10x to the 4th. So we are adding and subtracting, so we must have the same variable and same exponent. And you keep that same variable and exponent. You just combine the coefficients. That's going to be negative 7 minus 10 x to the 4th. This is going to be plus 1 plus 3 x to the 3rd. Just combining those coefficients. And then the 2x minus 9 doesn't have anything else to combine with. So your final answer, negative 7 minus 10, same sign, so we add and keep the signs. That's going to be a negative 17x to the 4th. 1 plus 3 is 4, x to the 3rd. And then bring down that plus 2x minus 9. And that's going to be your final answer. Okay. Simplify. 2x minus 1, all that's squared. Do not do this. Oh, that's 2x squared, and that's 1 squared. Done. No, don't do that. Okay. I know I'm being extra, but don't do that. So what do we do, Ms. Forsythe? All right, so you are squaring a binomial. So that's actually 2x minus 1 times another 2x minus 1. So let's FOIL this. So FOIL first, 2x times 2x, outer, 2x times negative 1, inner, negative 1 times 2x, and then last, negative 1 times negative 1. So that is distributing basically, but everybody calls it FOIL. This is a way to help follow what we're doing. But FOIL only works for a binomial times a binomial. Like 2 terms times 2 terms. Now let's clean this up. So 2x times 2x. 2 times 2 is 4. X times x is x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x, another negative 2x. Then negative 1 times negative 1 is positive 1. All right, so now we have like terms here. Negative 2x minus 2x is negative 4x. I cannot combine this with the 4x squared because they don't have the same exponents. They have the same variable, but they must have the same variable and exponents. And I'm just going to bring down that plus 1. So your final answer is just that, 4x squared minus 4x plus 1. Okay. And there we go. Okay, so now 26, simplify. Let's see. Sorry about that. All right, so now we're going to divide kind of individually. So let's focus on, I'm going to write it bigger because I write big. I need to see it big. Okay, so let's start with 6 divided by 3. That equals 2. X to the 9th over x to the 5th. So we're dividing exponents with the same base. So we subtract the exponents, and you can put the difference wherever the bigger exponent is. So x to the 9th over x to the 5th is going to be x to the 4th at the top. And then same thing here, y to the 8th over y to the 2nd. We're just going to subtract the exponents, and we're going to put the difference wherever the bigger exponent is, which in here is the top as well. So that's going to be y to the 6th. And that's your final answer. And just so you know why we're doing that, so let's look at, say, the x one. So x to the 9th over x to the 5th. That's the same thing as x 9 times. 1, 2, 3. Over 5 x's. And if we cross out where they cancel, how many is left over? 4 at the top. So that's why we do what we just did. But that's your final answer. 2x to the 4th, y to the 6th. All right, 27. Simplify 3 to the 0 over a to the negative 5th. So there's 2 things we know about this. So anything to the 0 power is just 1. So 3 to the 0 is 1. And then now we have a to the negative 5th. Why did that just pop up? That was weird. Okay, so now we don't want a negative exponent. So to make a negative exponent positive, we move it to the other end of the fraction bar. I don't like to just say move it to the bottom, because here's a perfect example. The negative exponent is in the bottom. So you move it to the other end of the fraction bar. So this is going to move to the top to make it a to the positive 5th. That 1 is still there, and there's nothing left at the bottom. You can put a 1 if you want to. So what's 1 times a to the 5th divided by 1? That's just a to the 5th. Let's see, I have a question. How is the numerator 1? So that's a exponent rule. So any number to the 0 power equals 1. Like that's like a rule with exponents. So 3 to the 0, negative 2 to the 0, anything to the 0 power is 1. If you have 3 to the 0, that equals 1. If it's negative 3 to the 0, notice it's in parentheses, that equals 1. If it were negative 3 to the 0, no parentheses, the base of this 0 is the 3, not the negative. So that would be negative, like this would be 1, so the answer would be 1. But that's just a property of exponents. All right. Good question. Very good question. Come on, computer. All right, we're back. Okay. 28. So we're going to simplify. We're subtracting polynomials. So when you subtract polynomials, the first polynomial, you can just drop the parentheses and rewrite it. But the second one, you want to distribute that negative. So you're basically changing all the signs. This will become minus 9x squared plus 4x minus 8. And then from there, you're going to combine like terms. So we've got 4x squared minus 9x squared. I'll just write them all together. Then we have 6x plus 4x. And then negative 1 minus 8. So 4x squared minus 9x squared. That's going to be different signs, so we subtract and take the sign of the larger number. That's going to be a negative 5x squared. So that's done. 6x plus 4x is just 10x. That's done. And then -1 minus 8, they have the same sign, so we add and keep the sign, -9. And that's going to be your final answer here. -5x squared plus 10x minus 9. Okay, 29 is another example where we will use distributive property, or we can use the kind of shortcut to FOIL. So that's first, outer, inner, last. And that's just really saying, okay, distribute the 3x times the 4x, then 3x times -3, then distribute the -4 times the 4x, and then -4 times -3. We're out of room. Okay, so 3x times 4x is 12x squared. 3x times -3 is -9x. -4 times 4x is -16x. And then -4 times -3 is positive 12. And then we have like terms to combine here. -9x minus 16x, we have the same sign, so we're going to add and keep the sign. That'll be -25x. And then we're going to just bring down that 12x squared plus 12. So the final answer would be 12x squared minus 25x plus 12. Okay? Okay. Now, Chapter 5, we're now talking about factoring. So we have a polynomial here that we want to factor. Always when you're factoring anything, you always have a greatest common factor to factor out first. It has to be in all of the terms. In this case, there is no greatest common factor, or GCF, that we can factor out. So the next step is to decide we'll look at how many terms we have and then decide what method we're going to use. So we have 4 terms here, so we're going to use grouping. Okay, so it's xy plus 9y minus 5x minus 45. So let's group the first 2, and we're grouping the second 2. And notice that I included the negative in the second, because that's important. So the GCF of the first group is going to be y. So we factor that out, and what's remaining will be x plus 9. Now we're going to factor out the GCF in the second group, and we need to factor out a negative and pull out that negative. So between -5x and -45, the GCF is -5. And then what's left over is x plus 9. Now when you're factoring by grouping, you want to get what I call the twins. You want to get the same thing here. If you don't get the same binomial in there, then something went wrong. So now what you want to do is look at what's in common between these 2 terms. The twins, the x minus 9 is in common, so you're really factoring that out. And then what's the remaining? Y minus 5. And that's your answer. You can always go back and check your work by multiplying it back together. So we'll distribute, so that's going to be x times y is xy, x times -5 is -5x, 9 times y is 9y, and 9 times -5 is -45. And if you look at the original, it's the same thing. But this is your answer here. X plus 9 times y minus 5. And you could have written it the other way. You could have written it as y minus 5 times x plus 9. That would be the same thing. Okay, let's factor some more. So this is like a really big factor problem. I'm not sure why this is what I picked, but I picked it, so let's go. So we have 10x squared minus 27x minus 28. Yeah. Okay. Let's do it. All right, so and there's a lot of ways to factor trinomials. Depending on who your instructor is, there's so many ways to factor. I'm going to teach the way that I like to factor. So maybe it'll be new to you. Maybe you have a way that you like and you can stick with your way. As long as it works, it doesn't matter. Okay, so for me, I am going to notice that I don't have a GCF to factor out, unfortunately. So the next step is to do the AC method, which means to multiply A times C. So 10 times 28 is 280. So I'm going to rewrite my trinomial. I'm going to toss the 10 for now and write my new C. Okay, so now I want to think of two numbers. Well, first let me set this up. So I need to have x times x, and now I like to use what I call sign rules. I'm going to drop the first sign and then multiply these two signs together to get the next one here. So now I need two numbers that will multiply to give me 280 and subtract because the 280 is negative to give me 27. So this is a big number. So I'm going to kind of break this down to help me know. So 28 and 10, using a factor tree here. 5 and 2, 7 and 4, and 2 and 2. So I can use these numbers, this prime factorization, to help me get those two numbers. So let's think of my two numbers that can give me 280. And let me make this a little smaller so I have some more room. Okay. So let's see, I've got 14. So let me show you how, let's say you can't think of factors. You can kind of use your prime factorization to come up with some numbers. So it's 280. So I know 28 and 10 work, but that's not going to subtract and give me 27. Let's see, we've got 14 and 5 times 2 is 10 plus times 2 is 20. That's not 280. Yeah, it is. Sorry. That doesn't subtract to give me 27. Let's try a different combo. Let's see. 5 times 2 is 10, times 2 is 20, times 2 is 40, minus 7. That doesn't give me 27. Let's see. 7 times 5, so 35. 7 times 5. And then 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 35 and 8. 35 times 8 is 280, and 35 minus 8 is 27. Bingo! We found the one we want. So I'm going to always put the bigger factor first. So I'm going to put 35 and then 8. Okay. So now I'm going to go back. I have the 10 times 28 to get 280. Now I got to go back and divide the 10. So divide 10, divide 10. At this point, I'm going to simplify where possible. So let's see, 35 over 10, I can reduce both of those by 5. So 5 goes into 35 7 times, and 5 goes into 10 2 times. All right, and then 8 over 10, they can both reduce by 2. 2 goes into 8 4 times, 2 goes into 10 5 times. Once you have reduced the fractions, now it's time to slide it back up in front of the x. So we're going to take the 2, slide it here, take the 5, slide it here. So your factors are actually 2x minus 7 times 5x plus 4. And that's how I factor trinomials, where the leading coefficient is not an 1. All right. So like I said, you may have a lot of different methods. Other methods, that is completely fine. This is how I factor trinomials. Okay. 32. So we have 2 terms here. Let's check and make sure we don't have a GCF to factor out, which in this case I do not. So the next question is, how many terms do I have? And it's just 2 terms. So in this class, if a problem is factorable and you have factored out the GCF, the only way it can continue to be factored is by using the difference of 2 squares. And that factor pattern looks like this. A squared minus b squared equals a plus b times a minus b. So 64 is a perfect square because 8 squared equals 64. 49 is 1 as well. 7 squared is 49. So we can rewrite 64x squared as 8x, all of that squared, minus 7 squared. So by doing that, we can clearly see what our A and what our B would be. And then all you have to do is kind of plug them in using this factor pattern. And I like using colors, that's why I'm doing that. So that's going to be A plus B times A minus B. And that's it. It's just that simple. You just plug it into this factor pattern here. And that is it. Okay, 33. Now we're going to solve by factoring. So the way you do that is that you would solve it just like you would factor it just like we just did previously. And then once you get your factors, you set them equal to 0 and solve each individual equation to get your solutions. So we have a trinomial here, and we do not have a greatest common factor to factor out. And so we're going to start by setting up my binomials. So it's going to be m and m because it's m squared. I'm going to drop the first sign and then multiply these signs together to get the next one. So I have 108. I need 2 numbers that multiply to give me 108 and add, because 108 is positive, to give me 21. And I actually don't know of those numbers at the top of my head. So let's see. 2 times 54 equals 108. Let's see, 54, 9 times 6 is 54. 3 times 3, 3 times 2. So let me think of some combinations of numbers that will multiply to give me 108 and add to give me 21. So definitely 2 and 54, but that doesn't add to give me 21. What about 2 times 3 is 6, and 3 times 3 is 9, times 2 is 18. 18 plus 6 does not give me 21. What about 2 times 3 is 9, 6 times 3 is 18. Oh, I already did that, sorry. How about 4? 2 times 2 is 4. 3 times 3 is 9 times 3 is 27. That does not add to give me 21. Let's see here. What about 9. 3 times 3 is 9. Times 3 times 2 is 6. Times 2 is 12. And 9 plus 12 does equal 21. Yay! Found it. So it's 9 and 12. So you're going to put the bigger factor first. And it doesn't really matter here because they're both positive. So I'll say 12 and 9. So 12 times 9 is 108. 12 plus 9 is 21. But we got to solve this. So we're going to take each factor and set it equal to 0. M plus 12 equals 0. M plus 9 equals 0. That is that 0 product property. And then solve them each for M. So M equals negative 12. And M equals negative 9. And then in MAT0022C, it asks you to enter only one of the answers. So you would type either negative 9 or negative 12. Don't type both of them. Okay? All right. 34. The triangles below are similar. Let me make this bigger. Find the measurement of the missing side. So they're telling you they're similar, so you know that you can use proportion. So let's set up a proportion to solve this. So you can say 10 over 7 is proportional to the same type of ratio in the other triangle. So that would have to be x over 21. And so to solve this proportion, we're going to cross multiply. So 10 times 21, not 27, equals 7 times x. Now I'm going to leave it like this because when I divide the 7, I can actually do it a little easier. So if I leave it like this and then divide by 7, I did that because I can do 21 over 7. 21 over 7 reduces to 3. Right? So that's going to be just 10 times 3 equals x. So x equals 30. Or you could have, of course, said 10 times 21, which is 210, and divided it by 7, you would get 30. So either way, you get the same answer. Now, also, you don't have to do your ratio the exact same way. So let's say you did, let me make it a little smaller. Let's say you said, okay, 10 over x. If you do long over long, you would have to equal it to short over short. And then if you cross multiply, you would get 10 times 21 equals x times 7, which will give you the same thing that we had before. So it doesn't, as long as you're consistent with how you set up your proportion, then you'll get the right answer. Okay, this next question is another proportion problem. Okay, so if Devontae walks 4 miles in 42 minutes, then how far will Devontae walk in 111 minutes? So, if we compare miles over minutes, let's set this up. So if you can do 4 miles in 42 minutes, that's proportional to how far will he walk? So x miles over 111 minutes. So that's your proportion. So we're going to cross multiply. 4 times 111 equals 42x. And I don't really have a quick way of doing this. I'm just going to go ahead and multiply. That would be 444 equals 42x. For this problem, it says to write it as an integer or a reduced fraction. So we're going to divide by, oh, come on, computer. The computer's getting tired. Okay, we're going to divide by 42. And then now we're going to reduce this as much as we can. So let's see, I definitely can reduce it by 2. Actually by 4, right? No, not 4, so let's do 2. So if we divide both of them by 2, let me go up here. 444 over 42. We'll divide the top and bottom by 2. That'll give me 222 over 21. I think I can divide. Let's try by 3. I don't know. Let's see, can 3 go into 22? 222. So 3 goes into 22 7 times. 7 times 3 is 21. Subtract and bring down the 2. Yeah, 3 goes into 12 4 times. 4 times 3 is 12. So 3 can go into 222, and 3 can go into 21. So that'll be 74 over 7. And I'm pretty sure that's as far as it can go. Let me see if 7 can go into 74. So 7 can go into 7 one time. 1 times 7 is 7. Subtract, bring down the 4. And 7 goes into here 0 times. Yeah, I'm going to get a decimal. So that's not going to work. So I can't divide 7 into 74. So my final answer is just going to be 74 over 7 miles. And that's because the problem does ask in MAT0022 to write your answer as a reduced fraction. So you don't want to give a decimal. You want to write it as a reduced fraction. So that's why 444 over 42 would not be the correct answer because it's not reduced. So if it says reduce, make sure your answer is reduced. Okay, and then the last problem I want to go, no, I have a couple more problems actually. Yeah. All right, so simplify. Now we have a radical. You're going to have a couple of radical problems on your final. Mainly the ones that you see on your review will be on your final. So we have 10b to the 4th times the square root of 121 times b to the 9th times e to the 4th. Okay, so 10b to the 4th, that's already going to stay outside the square root. He's just going to hang out there, ready to work. All right, so the square root of 121, that equals 11. So we're going to write that on the outside, and then we're going to leave the b to the 9th and e to the 4th to deal with. Okay, so now b to the 9th. So this is a square root. It's like a little invisible 2 in there. So the way that you can do these is that you can write b to the 9th as b. So change that to an x, to include an exponent that's a multiple of 2. So what's the closest? The lowest number below 9 that is a multiple of 2. It's 8. So we can change b to the 9th to b to the 8th times b. And then e to the 4th is already, 4 is already a multiple of 2, so we'll leave her alone. So now why did I do that? Well, the square root of b to the 8th, 2 goes into 8 how many times? 4 times. That's going to be b to the 4th on the outside. So I still have that 10b to the 4th here. I still have this times 11. And then now I have times b to the 4th. And then I have this e to the 4th to take care of. So now 2 goes into 4 how many times? 2 times. So that's going to be e squared on the outside. Oh, I forgot about that b. Sorry about that. I forgot all about this lonely b here. That b stays in there. And then I have e to the 4th. So now 2 goes into 4 how many times? 2 times with no e left over. So the only thing left under the square root is this b. We still have this 10b b to the 4th. We still have the 11, and we still have the b to the 4th out here, times of e squared. So now I want to clean this up. So 10 times 11 is 110. b to the 4th times b to the 4th is b to the 8th. And then I have that e squared, and then I still just have that square root of b on the inside. Okay? You can kind of break this apart a few different ways, but that's one way you can do it. And you can do it at one time too, but I like to do it step by step by step by step so you can kind of see what's changing at each step. Okay. I think it was the last one on my, yeah, this is my last one. So a rectangular pool is 18 meters wide and 24 meters long. So let's draw that out. So we've got a rectangular pool, 18 meters wide, 24 meters long. If you swim diagonally across the pool, as you swimming, how many meters would you be swimming? So we don't know that. It's going to be x. Now, it's a rectangular pool, so I have a right angle. All the angles are right angles. So that means this is a right triangle. And the reason why that's important is that we can use Pythagorean theorem for this. And that is going to be a squared plus b squared equals c squared. So a and b, that's going to be the legs of your triangle. C is always your hypotenuse. So if I were to write this like what we see here, we can make this a and this b. This would be c. Let's use the theorem to set up an equation. So let's say we have 18 squared plus 24 squared equals c, or we'll say x squared. All right, so we got to figure out 18 squares. 18 times 18. I need some room. I need one more page here. One more page. All right. Okay, let's see here. So need a pen. 18 times 18. So 8 times 8 is 64. 8 times 1 is 8 plus 4 is 14. And then, yeah. Okay. And then placeholder, and then we have 18. We're going to add 4. 4 plus 8 is 12. Carry the 1. 324. So we have 324 plus 24 times 20. What is going on? 24 times 24. 4 times 4 is 16. 4 times 2 is 8 plus 1 is 9. Placeholder. 2 times 4 is 8. 2 times 2 is 4. And then we're going to add 6. 9 plus 8 is 17. Carry the 1. 5. So 576. So I need to add 324. I have a question. 900. Thank you. Thank you. I'm going to just go through and write it out just for anybody else who needs to follow. But thank you for that. So 324 plus 576. 4 plus 6 is 10. Carry the 1. 1 plus 2 plus 7 is 10. Carry the 1, and then we have 900. So 900 equals x squared. Now to solve x, we want to take the square root. I think my computer is freezing. Yep. It's about to come back. Come on back. There we go. We want to take the square root. Oh my gosh, come on, we're almost done. All right, so now x equals the square root of 900. The square root of 9 is 3, so the square root of 900 is going to be 30. Okay. All right, so the answer is 30, what was it? Feet? Meters? Meters, yeah, 30 meters. Okay, so went really quick through this review. Hopefully it was helpful. Kind of refreshed your memory on some things. If you have not, I want to show you, not my email, I want to show you, so the Math Depot has, well, the Depot, not the Math Depot, the Depot has a YouTube channel that if you don't know about it, you should. So I'm going to show you how you can check it out. Let me share this with you. Okay, this is my YouTube channel, but if you type in the search like Learning Support Osceola, then this Learning Support Virtual, oh, yeah. Oh, thank y'all. I appreciate y'all saying it helped. I'm glad you got. I really appreciate that. So Learning Support Osceola, that'll get you. Learning Support Virtual is this website. So this is a ton of videos that were recorded by tutors in the Depot, as professors, all kinds of stuff. So I mean, you can search within here. There's even playlists. So Professor Ponciano, she is a developmental math combined professor. So this is a great resource. So she records a ton of videos for her classes. So you can use these to review as well. Just like what's going to be in your final exam. You can even review actual content. So like if you go to, I guess, videos, if you search by a topic, so, I don't know, graphing, you will see tons of videos on graphing, all kinds of things. So this is from the Depot that you can use. So I know it's legit. It's from Valencia. It's here at Osceola campus. So, but it goes all the way up to like calculus. So there's tons of things here. I just wanted to show you guys that. So again, if you type in Learning Support Virtual in YouTube, you'll find it that way. There's also Smart Thinking that everyone at Valencia has access to. You can get to it through Atlas. And of course, we have the Math Depot here at the Osceola campus. I, pub the Osceola campus, that's where I am. But, all the campuses have learning support that can help you. So that is pretty much it. If there's are there any general questions that you guys have that I can answer? I'm recording this. I will email you guys the link so you can watch it later if you need to. But I guess that's it. So you guys have, a good weekend, study hard, and preparation is key for this. There's not going to be any trick surprise questions. Your review is very, very similar to the final. And please do the final review a few times with no notes, no calculator. Try to do it in one sitting a couple of times so that when you actually do the final, you won't be thrown off by, the testing conditions. So if you have any questions, I'm in the depot next week. We'll be open during final exam week if you want to get some last minute studying in. So with that, I will let you guys have the rest of your Friday and have a good weekend. Thanks so much.